Okay, good morning, everyone.
Good morning, sir.
Good morning.
Okay, let's see. So yesterday we have seen about in the previous slide we have seen about star connection and per unit, and today we'll see the other connection, that is your delta. We'll see delta connection in per unit, and then we will be proceeding with the star delta conversions. Then we'll go with the subsections. Okay, so let's start. So this is your delta connection in per unit system. Okay, this is what we are going to see. Okay, so let's okay. So in this, we know in a delta connection that VL is equal to V phase, right? Voltage is same. That is your, this one is your VL would equal to your, right? And whereas current is √3 IPH, right? That means this IL would not be equal to this IL. This is what we're going to see. We'll see impedance and power as well in this delta connection. Okay. So as we know, our per unit equation, that is, if we go for okay, if we go for line parameters, considering your line parameters, and over here phase parameter. Okay, so we could write VL per unit by VL actual by VL base. Okay, A is for actual and B is for base. Okay, and this, whereas your phase per unit would be your V phase actual by V phase base, right? So we could say in this also in delta connection as well. Okay, be it VL per unit would equals to B phase per unit, right? This is what we got in your star connections, and it is same for your uh, delta connection as well, right? Now, second is for current. Okay, for current we know your IL per unit would be your IL actual by IL base, right? Which we further, if we convert this IL, we know IL is your root 3 IPH, right? And your this would be changed as your IPH base. Okay, root 3 IPH base, fine. So this would include your IPH would be equals to IPH base. Okay, so again we could conclude over here, right, that IL per unit, okay, is equal to I phase per unit. Okay, so ultimately what we get, be it your current, okay, or voltages, okay, are same considering any, okay, considering any either line parameters or phase parameters, okay, when it is considered in per unit system. This conclude either be it current or voltage, okay, both are same for phase and okay, it's same for both, right? This we got. And another point what we get is this per unit system is free of 3n root 3 concepts. Okay, there is no three the conversion concept what we see in the actual parameters, okay, when we calculate in actual, okay, in per unit system. So these two things are being noted out, either we are dealing with star or delta connection in per unit system. Okay, now the next terminology what we are seeing is your impedance part. Okay, so what we know impedance, this per unit would be written as your V base by I base. Okay, so and we know our two base parameters, that is your V and S. Okay, so we could convert this, and this Z is also derived base and I is also base. Okay, so if we convert or we multiply your V base as we have explained in star connection, will go in the same manner in this also. Okay, we multiply V base in denominator and numerator part, so it could be written as V square base by S base. Okay, that I base into V base is your S base. Okay, so Z per unit would be written as your V square base by S base. Okay, so let's assume this per unit is for single phase. Okay, this is the balance concept. So first we'll write this entire thing for a single phase. Okay, so if we consider this for per unit would be equals to, okay, and if we write, okay, be it as we know that in delta connection your VL is equal to VPH. Okay, so if we assume this as VL and this as your V phase, okay, V phase, then this is single phase base. Okay, we can write in the both the manners. Okay, we will have no effect on this, either we take this PH or VL. Okay, whereas in star, okay, in star what we have seen that if it was for VL base, okay, on converting, no, not now, I will tell you when in three phase concept. Okay, I will tell you in three phase concept. Okay, so let's as we know this is your balanced, okay, this is your balanced circuit. So if it is for single phase and we are trying for three phase, what we'll have only 3 VPH base by your 3 single phase base, right? Which we could also write as 3V square VH base by S 3 phase. Okay, this is 3 single phase and we have converted into single 3 phase base. Okay, now we'll see this concept in star and delta part. Okay, now what is your particular, what is your Z per unit? It is written for, let's take for star over here and delta at this corner. Okay, this per unit was 3 V phase. Okay, 3 phase base by S 3 phase base, right? And whereas in this also till here it is similar to that. Okay, VPH square base by 3 base. Okay, now there is a small changes in star and delta. Okay, will and in only regarding your Z base, we'll see. Now in this we know your VL equals to root 3 VPH, right? We know this part. We'll write over here. We know that your VL is your root 3 VPH, and in this we know VL is equals to VPH, right? So if we could convert this segment as we have done in root 3 VPH base, okay, of whole square, it is similar. If we break this bracket, we'll get the same reading what data it is given over here, right? So this could be converted as your VL square base, right, as S3 base. Okay, whereas in delta we know this VL is V phase, so our Z per unit would be 3 VL whole square base by S3 phase. Okay, so this is the difference for star and delta. So what we conclude? We conclude that therefore this del base is more or greater than your just star base. Okay, so this is what a small changes or small modification is there in your delta. So we could conclude that this just delta base is always more or greater than your z per unit in base. Okay, this is what I was telling, and this concept is only meant for star, and this concept is only meant for delta. Okay, this is what is to be highlighted and is to be noted down. Okay, rest everything would be similar. Okay, if you see either be your star or delta part, everything, all the concepts are same, only small changes is. That's why on the previous class as well I have written for z per unit that this concept is only for star, and over here also this concept is only valid for delta connections. Okay, concluded that your z per unit or z base, okay, this z base is greater than your z base in star. Okay, next is our mm, next is our power ratings. Okay, or power. Okay, so we'll see about this segment in this, and we'll also see some of the second. Okay, right. For power, we know we have also already seen in your star connection, it will follow the same sequence and same concept. In this also we know s. Okay, for line parameter will do parallelly for both. Okay, okay, we know your s is your root 3 vl il. We know s is 3 vp and vph. So I'm writing as a p. Okay, for okay, we know these two terminologies, and we also know p is your root 3 vl il cos phi. Q is your root 3 vl il sin phi. Okay, and in phase it's your 3 vph iph cos phi, and q is your vp ip sin phi. Okay, so we are aware of this particular concept. Okay, so if we convert this entire thing in per unit segment, so what will be it? Your s per unit would be your s by s base. Okay, that will be your root 3 vl il by root 3 vl base il base. Okay, so that could be written as your v per unit into I per unit. Okay, if we go for p per unit, it will be p by, again it will be your base part, so it will be your root 3 vl il vl il cos phi by root 3 vl base il base, which could be written as v per unit I per unit. Okay, cos phi. Similarly, for q per unit as well, it will be your q by s base, which would be your v per unit I per unit sin phi. Okay, it will be your L. It is for the line parameters. Okay, Similarly, if for phase parameter, your S would be your S by S base. That could be written as your 3 VP IP by 3 VP base IP base. Finally, we'll get per unit IP per unit. Okay, your S per unit will be. Similarly, for P and Q, it will be your VP per unit IP per unit cos phi VP per unit IP per unit sin phi. Okay, these are the relations what we see, which concludes, okay, what we have seen in star connection, that first point is your 3 or okay concepts of 3 root 3 is not valid for either be your delta or star connections. Okay, this is the one thing, the this is one thing what we know. Okay. Even if we draw your impedance triangle, you could get similar thing. Okay, you could draw, okay, in per unit. Okay, for star or for delta, it will be similar as we have studied in star or delta, or in numeral terms, okay, in actual terminologies. Okay, now what now we are going to see is your concept of delta to star conversion, okay, in per unit system or per unit representation. Okay, this we are going to see. Let's take one. Okay, take any random values. Let's we'll take only one. Okay, let's take one. Okay, and what we have to do is we have to convert this particular thing in your delta. Okay, so what will be the your this delta equivalent of this circuit? What will be the delta equivalent of this circuit? What will be the values? Can anybody say? Anyone could say what will be the delta equivalent of this circuit or star equivalent of this circuit, I'm giving all values similar. Okay, let's take as 1 ohm, 1 ohm, and 1 ohm. Okay, so can anybody tell me?
So,
Yeah,
so the delta values are 3 ohm, 3 ohm, 3 ohm.
okay. So this equivalent would be your 3 ohm, 3 ohm, 3 ohm. And for this,
1 by 3, 1 by 3, 1 by 3.
perfect. Okay. So in actual conversion, if we see, we take these parameters, okay, if this is a star and this is a delta, okay, of same rating. So we could see the actual equivalent, okay, of this star to delta are different, and your actual star equivalent of this delta is different. Okay, so both are not same, but in per unit system, okay, in per unit system we'll see, okay, if we have converted this in a per unit, so your star and delta, okay, would be same. Okay, so you could directly, okay, you do not require to convert or do multiply. If you are converting from star to delta, you don't have to multiply this. Okay, so whatever per unit value, let's take this is as a per unit, this is your a per unit, a per unit. So the all, if you are converting to a delta, so its value would be your a per unit only. Okay, so we'll see how this is gonna be. Okay, we'll see by solving this particular thing only. Okay, so let's take so we know that z base for delta, sorry, z base for star is your vl square base by s base, right? And for delta base is your 3 of pl square base by s base. Okay, so from this only you could sense, if we convert this particular unit into your star, it will be definitely different. Okay, so we'll see how. Okay, this is what we are getting. Okay, let's see the actual thing or actual. Okay, Chandan is joining now. Good. Let's see. So if we calculate these values, okay, we'll solve on this page only. We'll solve on this page only. Okay, if we calculate your z base, okay, for y, and your, let's calculate for this, it is your one way. Okay, let's assume your base value, it is given as given as your MVA. We generally deal with MVA, so we'll write 1 MVA, and V base as 1 kb. Okay, we'll take only one. This is the example, so we are taking only one parametric. Okay. If we calculate this, what will be what will be the value for Z base? Z base is your uh, V square B by SB, right? So we could write this your N into 10 to power 3 by S base is your 1 into 10 to power 6. So what will be the value? It will be detected. So it will be 1 only, right? 1 ohm. And whereas for Z base, for delta, it will be your 3 VB square by SB. So if we solve it, it will be 3 into 10 to power 3 by 1 into 10 to power 6. Okay. So it will be your 3, right? This what we have got. Okay. Now, if we calculate per unit system, okay, let's over here we are doing with delta, so we'll write of delta. So we know this is your 1 by 3. So what will the value will get? Around 0. What value will get? 0.33. Is it?
Yes, sir.
Okay, not ohm, it will be in per unit. Okay, this is a per unit value, right? Now, so what we have got, this delta in per unit system would be represented in this manner, whose value is 0.33, 0.33, 0.33, right? And if we convert this in form of actual, okay, in what how we were doing or we were calculating in actual, what we are doing is you were dividing by 3. Okay, so if we convert this into this form, so it will be your 0.11, 0.11, 0.11. Okay, if we follow the actual terminology, right? If we follow the actual terminology, but in starting only I have told that this concept is wrong. Okay, will whenever we are converting your delta to star in per unit, okay, so these values, okay, these values would be same. Okay, it will not follow the similar pattern what we were used to following in actual quantities. Okay, so this would be not valid. Okay, we'll also calculate for the y. We'll write over here as 1 ohm. We'll erase this segment. Okay, this is for delta. For z per unit for star, this was your 1. Okay, so it is uh, per unit is your actual by base, so it will be 1 by 1, so it will be in 1 per unit only. Okay, is it? I'm right, it will be 1 only. actual by base. As base also we have gotten, okay. So we know these two unit, okay. We know the per unit value, it will be your 1 per unit or per unit, and for this it would be your 0.33 per unit, okay. The per unit now, what we are going to see now is the actual concept, okay. So what will be happen if we see these thing, okay, in your this part, okay. Okay, so how we would be seeing that is, we know like per unit, if we go for let's go with y, okay, the star connection, okay. Per unit, what we know is VL whole square base by S base, right? We know this. And for so so if we convert, okay, wait one second, not with this part. Mm, not with this, okay. We'll see with the yeah, we'll see with the z parameter only, where what we have today is, if we convert this to star, okay. If we are converting your delta to star values, okay. Let's write what we have to find this. Natural parameter is your a by 3, a by 3, a by 3. Okay, but we have to get right. Okay, right. We'll see in this. Your z per unit is delta actual by your z base value, okay. Okay, if we see, if we consider this segment only, okay. So we'll write delta, we'll write delta, okay, right. Now what is, now we are converting this into your